Okay, second page. You select a card from a standard deck. Find the probability that it is a 4 or an ace. All right, so I'm going to circle the word or here and put plus so that I remember that or means plus. Probability that it's a 4 or an 8, and it always looks like this. I've got the probability of 4 here, the probability that it's an ace here, and here's the overlap. So how many cards in the deck are a 4? 4. 4 out of 52. And how many cards in the deck are an ace?
4.
Yep. And how many cards are a 4 and an ace at the exact same time?
8.
Nope.
Oh, wait, no, I think that's.
Like one card that is a 4, both a 4 and an 8. Not, right? Not possible? That's because they're mutually exclusive. So when it's mutually exclusive, there is no overlap. C answer to this problem would be 8 out of 52, which is definitely reducible, but I don't want to reduce fractions today, so I'm just going to figure it out in decimal and write 0.154. So the chances that you would pick up a 4 or an ace from the deck is 8 out of 12, 8 out of 52, because there's 8 of them out of 52, 0.154. Okay, I feel like we're understanding it so far. Next, you roll a die. Find the probability of getting a number less than 3 or rolling an odd number. So I'm going to add something and subtract something. All right, our first probability is getting something less than 3, and the second one is getting an odd number. This is the overlap. On a regular dice, how many numbers are less than 3? 2. A 1 or a 2, right? So I'm going to write 2 out of 6 here. And under here, I'm going to write a 1 or a 2 counts in that category. All right, how about odd numbers? How many odd numbers are there on a dice? 3. 3 out of 6, that would be a 1, a 5, or a 3, right? Overlap. 1. Do you guys see how, if I'm trying to figure out right now, probability of you rolling less than a 3 or rolling an odd number, if I added these together, I'd get 5 out of 6, which is really not possible because we know that a 2 wouldn't be an odd, well, sorry, a 2 would count. A 4 or a 6 wouldn't count, right? Because they're not less than 2, or they're not less than 3, and they're not odd. But the overlap is, do you see how we counted a 1 twice here? So we're subtracting that overlap. We're subtracting the numbers that were less than 3 and at the same time odd, which makes 5 out of 6 minus 1 out of 6 is 4 out of 6, or 2/3, which is what, 0.667? All right, you try A and B with your partner. Ace does not count. Ace has no face.
This is another fixed
No,
number.
two, right, so you get doubles for some of them.
And then heart should be 13. And then there should be three that overlap.
So you do 2 plus 6. So I think the sum of going to 3 12s. 12 sides to the die.
Yeah, which way to that?
No, plus 1.
Sounds like
Wait, how do you make that doubles for some?
because, so, there's 13 hearts, but each like suit of cards has the king, queen, jack, and so the 3 base cards are in the hearts. So,
Are you guys working on C?
yeah.
How did you guys get started? C,
Like for which power?
just the whole thing.
Let me help with C.
Oh,
Yeah.
All right, let's start at the top. Find the probability of rolling a 6 or an odd number. Okay, probability of rolling a 6 is 1 out of 6, right? Probability of rolling an odd number is 3 out of 6. And there's no overlap there.